Ohm's law. Ohm's law states that at constant temperature and pressure, potential difference across the ends of a conductor is directly proportional to current passing through it. Let V be the potential difference across the ends of the conductor PQ, and I is the current passing through it. So V is proportional to I, or V equal to a constant into I. That constant R is called resistance of the conductor. So R is the resistance of the conductor. Now what is the resistance of the conductor? It is the hindrance offered to the flow of current through the conductor. Or resistance is the ratio of potential difference to current through the conductor. How to define the SI unit of resistance? SI unit of resistance is ohm, which is equal to volt divided by current. Current is unit is ampere, or 1 ohm is equal to 1 volt by 1 ampere. 1 ohm is the resistance. When 1 volt potential difference is applied, a current of 1 ampere flows through it. Or when 1 volt potential difference is applied across the ends of the conductor, and if 1 ampere current is passing through the conductor, then resistance of it is 1 ohm. Let us see how resistance depends on length of the conductor. Look at this diagram. In this diagram, two identical conductors of length L each. Across each conductor a potential difference V. They are in contact with each other. The combination has a total potential difference of 2V and total length 2L. A be the area of cross section of the conductor which is uniform throughout. If I is the current passing through the conductor, then 2V is the potential difference applied. What is the new resistance of the combination of the conductors? We know resistance is equal to potential difference 2V divided by current I. Since they are in contact, they are in series, the same current passes through it. Or R dashed is the new resistance, which is 2 times V by I. In the previous case, already we had seen V by I equal to R. Or the new resistance is R dash, which is equal to 2 times R, which implies that resistance of the conductor is directly proportional to length. Let us call this equation number 1. Now what happens if the area of cross section is varied? We consider the same conductor of area of cross section A and potential difference V across it having length L is being split into 2 halves, and each half of the 2 conductors are in contact as shown in this diagram. If I is the current passing through this combination, where Potential difference across ends of each conductor is V. As the current I reaches the combination, it gets split into two parts. I by 2 current passes through the first half and remaining I by 2 current passes through the second half of the conductors. And when it reaches the other end, the two currents join as I and flows through the circuit. Now what is the resistance of the combination? Let the resistance be R double dash, which is equal to potential difference divided by current. We know current is I by 2, or R double dash equal to 2 times V by I, and already we know V by I is resistance R. Or as area of cross section decreases, the resistance of the conductor increases, or R is inversely proportional to area. Let this be equation number 2. Now if we combine equations 1 and 2, we get R proportional to L by A, or R equal to a constant into L by A, where the constant rho is called resistivity of the material of the conductor. Resistivity rho equal to RA by L. How to define resistivity? Resistivity is R when A is unity and L is unity. Or resistivity is defined as the resistance of the conductor having unit area of cross section and unit length. We know for a cube having dimension unity, this area of cross section is unity and length is unity. Or resistivity is the resistance of a cube of dimension unity. So resistance of a cube of unit dimension. Now what is the SI unit of resistance? We know SI unit of resistance is ohm, and area meter square, length meter. So what about the SI unit of resistivity? SI unit of resistivity is ohm meter square per meter, that is ohm meter. That is the SI unit of resistivity. Resistivity does not depend on length or area of cross section. As length varies, area of cross section also naturally varies. Hence resistivity depends only on the material of the conductor. Already we know R equal to V by I, or V equal to IR. We know R equal to rho L by A, so I into rho L by A. What is V by L? V by L, V equal to I into rho L by A. So V by L equal to I into rho by A. And this I by A is termed as current density. It is represented by the symbol J, current density J. Now what is potential difference by length? Already we had learned potential difference by length is electric field E. Electric field E is current density into resistivity, or resistivity can also be written as E by J, or J equal to E by rho. But what is 1 by rho? 1 by rho is conductivity. Reciprocal of resistivity is conductivity. Or the expression for current density J is equal to sigma times capital E. So J is the product of conductivity and electric field. Current density is the current per unit area, which is also equal to E by rho. Thank you.